Hello all. I suppose this is the first technical lecture of this course, ME5194. Um, and in the next lecture or two, I will actually give a high-level overview of machine learning as a field. Uh, but for now, I would like to actually jump into doing some little programming and little data analysis directly. Just to give you a flavor of the kinds of things that we will be doing in the class, but perhaps this is the simplest possible thing that you should perhaps take away from this class. So I have my Matlab open, and if I type VR here, it lists the all the toolboxes that I've installed, and it looks like it's version 2020A. I think anything after 2019 B should be fine, but if you are able to do it, I would say go ahead and install the latest version. In any case, okay. Oops. Um, I pressed enter while having this selected, so I think it uh, took that as a command. Okay. So what do we want to do? What I want to do is do what's called linear regression, okay, in Matlab. Um, Now, before I have a couple of data sets here, very simple data sets, which we will examine in a minute. But before we do that, I'm going to create a new folder within this folder. This is my course folder for fall 2020. I'm going to create a folder. And I'm going to show some basic command line tools. So I can say programs in Matlab or something. Example programs in Matlab or something like that. And then if I want to change the name of the folder, I do that. And I've opened this. I'm going to actually copy these things or cut these things, cut and paste them into Matlab. I'm actually going to create another folder, perhaps mkdir stands for make directory. You can also, of course, create a folder this way. We can say a lecture 2 linear regression. And then I'm going to move these things in there. I moved it in there. Okay, so we can do things entirely in the command line, or we can write a script, MATLAB script. We can do new script. And in each folder, it's useful to know what programs are the main programs. So I usually name my main program root something something. It's just my idiosyncrasy. Some people might call that program main, M-A-I-N, blah, blah, blah. So I'm going to say root first linear regression or something. Okay. Now, using these words with just the first letter of each word capitalized is called camel case, and you'll notice that I use a lot of that in my variable naming and things like that. Okay. Okay, let me just open that. It's an empty file, and of course you want to close all CLC before you do anything in a MATLAB program. What does clear do? Clear clears all the variables, right? So if you have a equals 5, you can type a into the command line and it says a equals 5, but then if you say clear and then say a, unrecognized variable a, and that's because we've just cleared all the variables, okay? And then close all, of course, closes all the plots. So let me create a plot, a random plot in Matlab. I just created a plot. And and I can close all, and then the plot goes away, of course, and then CLC just clears the screen, clears the command line. So it just clears the command line like that. Okay. This is just visual. If you wanted to get back the history of commands that you've provided, you can press your up arrow and you can go up like so. That's a convenient tool. And if you wanted to just recall a command that starts with a particular word, let's say MK, and then press up arrow, you get that particular thing completed. Okay. Okay, so before we write this program, let me do a couple of things in the command line. So this is a data set. You can double click on it. It will load essentially that data set, and it says that there are a couple of variables, X list and Y list, each of which has 200 elements, like so. Now we can plot X list, comma Y list. Okay, I'm going to plot it. Looks like a mess, and that's because X list and Y list somehow has a lot of noise. When you by default plot X list and Y list, it connects all the data points by little lines. So if you don't know how noisy or how sorted your variables are, so you might want to plot it not the default plot, but using a marker like so, and plot it like that. Okay, so all your plotting are the data points, and you're not connecting them with lines. So XList, just so you know, looks like this, right? So XList is not even ordered from minimum to maximum. Similarly, Y-list is not even ordered. That's why if you actually connect the dots, there are these big weird connections from here to there and back to here and so on. That's why it looks like a mess. Okay. Okay. So that was just plotting. Okay. So this is familiar, hopefully, to all of you. But if you're not, this is a time to catch up and internalize these little tricks, or whatever you want to call them. Okay. So that's plotting. So let's actually do that here in the context of a program rather than the command line. Let's say loading a data set. Load. You can go data and then complete. What I did was, when I typed data and then pressed tab, it gives me all the things that are appropriate in that context. Data set, and then I press S, dataset1.mat, and then I can press enter. You can do that, or you can do this. Let me just write until there and then press tab. It gives me two options because this folder has two options. Oops. Press tab again, and then I select that, and then, okay, so we've loaded that. So if I run this thing, it will clear everything and then load all the variables stored within that folder, which are these two things. So the workspace, the current workspace right now, has these two variables. And then we can just go loading and plotting a data set. We can say, we do a figure 1, plot X list, comma Y list. Like that. Okay, so when I created this data set, I mean, this is just some random data. It doesn't have any deep physical value. This is just for illustration purposes. But when I created this data set, I made sure that I named the variable X list and Y list. Again, this is just an idiosyncrasy of mine, the specific word list. But I like to make clear that the variable is a matrix or a list, a one-dimensional array, or something else, right? So that is helpful. But it's not absolutely necessary, but these are just things that I think helps me keep track of what's what. I could have named them X and Y, but just calling them X list and Y list just makes it clear that there's a whole list of them, not just one variable. Um, and my principle is that, first of all, computer programs need to be human readable, right? If another human or after 5 years, yourself after 5 years is another human, really. So yourself after 5 years or another human looks at your code, it should be relatively obvious what you're doing if they know the programming language. And even if they don't know the programming language, somehow you should convey um, what you're trying to do with the program. I think that's very important, both in terms of communication, but also in terms of keeping in your own head straight um, what the programming is doing and so on. And I think clear programs are also less likely to be buggy. And clear programs are more easily debuggable, etc. Okay, so that's just a plot. We just plotted it. And of course, we can do X label, Y label, like so. And I put X and Y. And I can say a legend, some data or something, I don't know. Run it again. It just puts this legend somewhere, which you can move it around. Okay, so let's say we have some data. We have some input, we have some output. Let's say this is called the input, X. This is called the output, Y. It could be, for instance, in the context of mechanics, the input could be, so let's say you are doing some tension experiment. The input could be strain, the output could be stress, or the input could be stress, the output could be strain, whatever, right? It so happens that there is a linear relationship between those two things that I just mentioned, at least for small strains. But in any case, this could be anything. Some input, some output. Okay, so if we have some data like this, what is the simplest model you can think of that captures what this data is about? That sort of captures the essence of this data, right? So first of all, what is the most complicated thing, or what is certainly a complete model of this data? Something for you to think about for a second. Okay, so a complete model of this data is the data itself, in some sense. If you want to convey this data to someone else, you can just give them all this data. So in some sense, well, the data contains all the information contained in the data. That's kind of a tautology. But what I want you to think about is what's the simplest model that can capture the important aspects of this data. Okay, I'm sure all of you think, okay, a linear model, like y as a function of x, a linear function of x maybe is a good model of the data. Okay, so let's actually fit a linear model. Now I'm just going to use a function in Matlab that allows me to do that, but then we will see the theory behind it in a minute. And you may have used some versions of this or done versions of this in the past. Right? So this is just the simplest thing we're going to do in this course, but we will build on this and make things more and more sophisticated in the coming lectures. Okay, so fit a linear model. It turns out that Matlab has so many different ways of fitting a linear model, maybe 5, maybe 10 different functions. I don't know. I can certainly think of 4 right now that does this job and will give you essentially the same answer. And there's a few more that will give you slightly different answers. In any case, one such command is called fitlm, fit a linear model, fitlm. Then if you go help fitlm, it's this pretty sophisticated function, and there's different ways of inputting data to this function. Okay, But one simple way of inputting data to this function is linear model equals fitlm of the inputs and the output. Okay, so let's just do that. L save, press enter. Okay, it took a while. I think maybe that's because my computer is struggling a bit, but because of the video capture, perhaps. But it's usually takes like a millisecond or something. It's a very fast program. Okay, so when I run this thing, because I didn't put a semicolon there, it output the results of that function. If I put, of course, a semicolon there, it will have no output here. But of course, you can still recall the linear model LM. Okay, let's look at what it says. It says linear regression model y tilde 1 plus x1. This is Matlab short form for saying y is linearly related to x1 in this case, which is x. There's a constant term and then there's an x term, is what it's saying. And the constant term is 2.9627, blah, blah, blah. And the linear term, the coefficient of x, which they're calling x1 by default, is 2.0083. Okay, so so what we want to do, let me just write some comments here. The previous line fits a function of the form b0 plus b1 times y equals b0 plus b1 times x, where b0 and b1 are constants. This is, of course, the equation of a line, right? So this is just an equation of a line. And let me just see, now how do you get b0 and b1 from this stuff? Like, this is the output, this is the screen output, and all this information is stored in this variable called lm. How do you get all this? So this variable is what's called a Matlab struct. Okay, it's not an array. It's not like Matlab has different data types, and this is a particular kind of a data type called a Matlab struct. If I say lm dot and then press tab, you will notice that it, like, you can actually sort of use these functions slash variables associated with that structure. Okay, so but it turns out that what we want is lm dot estimate or lm dot coefficients. So b0 and b1 are coefficients, and then if I press dot and press tab, there's like a few different sort of coefficient related properties. One of them is called the estimate. These are the estimate of these coefficients b0 and b1. Okay, estimate. If I say that lm dot coefficients dot estimate, it actually gives me these two coefficients, the constant term, which is b0, and then the coefficient of the linear term, b1. Okay, so what I'm going to say here is b0. So I'm going to say, let's pull out the coefficients b0 and b1 from the Matlab struct lm. So let's copy this thing, copy, paste. This is the first element, and then the second element is paste 2. Okay, save, and then I can run this thing. And then you can say B0 is that, B1 is that. Okay. Now, if you want to see more decimal points, you can go format long, B0, B1, right? So Matlab doesn't reveal to you what the what all the digits are, but they're there if you want to see them. Okay. What next? Okay. What would you want to do next once you have computed these best fit coefficients for a line that sort of best fits all this data? Okay. What would you want to do? Okay. Let you think about it for a second. Okay. So what would we want to do? We want to plot the line, right? So we want to plot the line. Now to plot the line, it's just a line, right? So how do you plot a line? Plot the best fit line. To plot the line, let's define XList for plotting. This is a new XList. Let me actually plot it sort of in a very concise manner, and then I will expand this. Plot. Okay. When you plot, of course, you want to do x comma y. X goes from 0 to 10, 0 to 10. And then y, what does y go from and to? Y basically is B0 plus B1 times 0 to 10, okay? And then maybe we can make it red or something. Maybe I'll just suppress the color and let Matlab pick default colors. Okay, let me just run this thing. Okay, we just have this line. What happened? Something to think about. Okay. So when I program, I usually intentionally miss things so that you can think about what happened, and it's a teachable moment. So of course, what happened is, well, what would we have wanted? We would have wanted this line overlaid with the original data. And to do that, we have to hold on so that the new plot doesn't overwrite the old plot. Okay, there you go. The old data and the line. Of course, the line is very faint. We can increase the line width to, I don't know, just try it out. That looks good, maybe. I don't know. Okay, that looks pretty good to me. And you can change every property of your plots inside your code by doing things like this, okay? If you want to see all the properties that you can change, you just set the plot equals h, just run it, and then you can type h and enter, and these are all the properties that that line has, and you can change every single one of them. In fact, there are even more properties. So that line, that thin red line, has all these properties, and you can change them all. And one way to change them is go set h comma line width comma 2. I'm going to place this here so you can see it as I press enter. I'm going to press enter here, and you will notice that the line width changes immediately. Okay. Okay, so really you can change like a million things about, or 20 different things about this line. So you have very fine control over it. But if you don't want to worry about all that, I would just not set it equal to a variable and just go line width comma 2 or something. Okay. And then because the legend now says data 1 or something, I would put the legend here, some data, and then say best fit from fitlm or something. Okay. Okay, so I would like your figures to look at least like this, where you have some legend, properly labeled axes, the programs to be well commented like this, like tell us what you're doing, etc., and so on. Okay, and it's not too hard. You just have to think about it for a couple of more minutes. Okay, what else can we do? We can do a variety of things here, but I'm going to quickly switch to doing theory in a minute. But something I want to quickly do is, instead of doing this 0, 10, blah, 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 which makes this line sort of a bit inscrutable or like hard to understand. I'm just going to say xlist for plotting equals 0, 10, and then or xlist for best fit line, something like this. Okay, and then I'm going to say ylist for best fit line is basically this thing. This is ylist for best list line, which is b0 plus b1 xlist for best fit line. Okay. Copy, paste, copy, paste, save. Okay, let me run this again. And it looks identical. All that we have done is made, hopefully, these two or three lines a bit better. That's all. Here we just have 2 points, 0 and 10. So this line really is made up of 2 points being connected by a line. If you're plotting curves and so on, you may need more points along the way. So maybe we can just say, instead of saying 0 to 10, we can say linspace 0, 10, 100, and then save, run. It looks identical because it's just a line. A line doesn't look different whether you have 2 points or 100 points in between. But if you had a curve and you just plotted xlist and ylist that consisted of 2 points, then the curve will have only the final and the initial 2 points connected by a straight line. But then if you had 100 points, then you could see a whole curve. For instance, if you were fitting a quadratic model instead of a linear model, then it would be better to plot it with 100 points, or actually correct to plot it with 100 points instead of 2 points. Okay, so I'm going to end the video now. I guess we will now switch to doing theory and see where all this takes us.